Hello everyone, welcoming you to Sourav Sir's Classes. And today we are looking at the GATE 2024 Economics paper, question number 43. So consider a Cobb-Douglas utility function given by u of h is equals to 24 minus h to the power 1 minus alpha into wh to the power alpha, where h is the number of hours spent on working per day and w is the wage per rate. If alpha is equals to 1 by 2, then the corresponding labor supply is equals to how much? Okay, so let's write down the utility function. U of h is equals to 24 minus h to the power 1 minus alpha wh to the power alpha. So for utility maximization, what should we do? For utility maximization, differentiate u with respect to h and set it equals to 0. So this would be wh to the power alpha 1 minus alpha 24 minus h to the power minus alpha into minus 1 plus 24 minus h to the power 1 minus alpha w to the power alpha alpha h to the power alpha minus 1 is equals to 0. So that implies, so if you take 24 minus h to the power 1 minus alpha wh to the power alpha common, then you'll have 1 minus alpha 24 minus h raised to the power minus 1 into minus 1 plus alpha w into wh to the power minus 1 is equals to 0. So this implies 1 minus alpha into 24 minus h is equals to alpha w into wh to the power minus 1. So that is 1 minus alpha divided by 24 minus h is equals to alpha w by wh. So the w and w will get cancelled, and then you can cross multiply. H minus alpha h is equals to 24 alpha minus h alpha. So this will cancel out. So h is equals to 24 alpha and alpha is half. So this is 12. So that means the correct answer would be the corresponding labor supply in hours is 12. Thank you.